Assalamu alaikum everyone. In this lecture we will study about the packing fraction. In the previous lectures we will learn about the rank Z. So it is the effective number of spares in one unit cell is called rank, that is Z. So the packing fraction formula, the packing fraction definition, we will learn it in this lecture. So it is the fraction of volume occupied by the sphere in one unit cell. That is a definition of packing fraction. And if we will talk about the formula of packing fraction is equal to volume of spheres in one unit cell division by volume of cube. So the volume of cube is equal to a cube. Why? Because this we consider this is a. If this is a, it is also a, and it is also a. So the volume of cube is equal to a cube, and the volume of one sphere is equal to 4 upon 3 pi r cube. Effective numbers of sphere is equal to Z. So the total volume of sphere is equal to Z into 4 upon 3 pi r cube. So the packing fraction formula is equal to Z into 4 upon 3 pi r cube division by a cube, because the packing fraction formula is effective numbers of sphere in one unit cell division by volume of cube. Volume of cube is equal to a cube. Now we will apply this packing fraction formula on the simple cubic. So we know that the effective numbers of sphere in cubic is one atom. One atom is in the inside the cubic for simple cubic. So Z is equal to 1. If the Z is equal to 1, A is equal to 2R. I just explain you. It is a summary. The simple cubic. For the simple cubic structure, the rank is Z, and the rank which is Z, that one is 1. And for BCC, body centered cubic, its rank become 1, and the face cubic center, its rank become 0. So the relation between A and R, 2R is equal to A, 4R is equal to A under root 3, 4R is equal to A under root 2. If you will learn it, then your all formulas of packing fraction become so easy. So please learn this summary. So here is Z is equal to 1 and A is equal to 2R. So we will put these values on the packing fraction formula. The Z which is equal to 1, we will put 4 upon 3 pi r cube division by a cube. Division by a cube. A is equal to 2R, so we write A is equal to 2R. It is the whole cube, so it becomes pi upon 6, that is equal to 0.52. So here is 52% occupied and the 48% weights. In other body centered cubic, packing fraction for body centered cubic, here spheres are present at corners plus body centered. So we can put Z is equal to 2. Z is equal to 2 because here is the effective numbers of spheres is 2. Here is 2. And if we will talk about 4R is equal to under root 2, that means A is equal to 4R upon under root 3. Okay, so I will explain you that there is atom and there is atom are present on the body center. So its radius is R, its radius is R, its radius is R, and its radius is R. So how many radiuses is present in this cubic? Here is 1, 2, 3, 4. 4 are present in this cubic. So 4R is equal to under root 3. Why it is under root 3? Just look here, we draw a line. If we draw a line, it is a, we know it is a, and it is under root 2a. We was learned on that formulas, on the mathematic formulas. If one side is a and the another side is 2a, then the third side is under root 3a. We was learned. So here is, we know it is a, and it is a, according to the Pythagoras theorem. Yeah, according to the Pythagoras theorem, it is a, it is a. So it becomes the under root 3a according to Pythagoras theorem. So 4r is equal to under root 3a. So we will find the r is equal to under root 3 upon 4a, and a become 4 upon 3 under root 4r upon under root 3. It is become a whole cube because a whole cube we know it. So it result become 0.68. That means 68% occupied and the 32% is void. Fraction formula for face centered cubic. If we will talk about the Planck fraction formula for face cubic, so the spheres are present at corner plus face centered. We can consider it is a, and it is a. It is under root 2a. It is, and the another side is under root 3a. We was learned in recently. So the length of face cubic, length of face diagonal is a under root 2, and then a under root 2 is equal to 4r, because here is also 4r present by one atom backside, one atom front side, and also present in the corners atom. So z is equal to 8 into 1 upon 8 plus 6 into 1 upon 2 is equal to 1. We was find z. What is z? 8, here is 8 atom, 1 2 1 2 3 4 5 6 7 8. 8 atoms. You can show 4 atom here and 4 atom here. There is become 8 atoms. So 8 atoms are present, and each atom have 1/8 part inside the cubic. 1/8 part of every cube. Then we will multiply 8 into 1 upon 8 plus. Here is 6 cubics. Here is 6 atoms, which is on the faces. 6.5 of the each atom part inside the cubic. So here is 6 into 1 upon 2, that is become 4. Here is 4 atoms are inside on the cubic. Its z become 4. So the Planck fraction is equal to z into 4 upon 3 pi r cube upon 1 cube. So the z become 4. Here is z become 4. We can put z upon 4. Z is equal to 4. 8 into 4 upon 3 pi r cube, pi r cube upon 4r, which is a cube. Here a is equal to is equal to 4r upon under root 2, 4r upon under root 2, and it have also become cube. So it be 74%. So here is 74% of 74% is occupied, and 21%, 26% is void. So it is the most effective packing takes in FCC. So here is in this cubic, in this face centered cubic, it is effective packing because it have 74% occupied and just 26% of voids. So it is a summary. Then the packing fractions: 54%, 52% in simple cubic, 68% in body centered cubic, and the 74% of face centered cubic. And now we will study about the density of cubic crystals. So the formula of density is equal to mass of sphere upon volume of cube. So here is volume of cube.